Hello, you're welcome to this lesson. In this video, you're going to learn about equilibrium of particles. So we define equilibrium as the condition in which the resultant of all forces and moments acting on a body is zero. So that's what equilibrium is. So you see that we have three equations here. The first one says that the sum of forces in the x direction equals zero. The second says the sum of the forces in the y direction equals zero. And then the third says the sum of the moments acting on the body should be equal to what? Zero. So those are the three equations that we use when dealing with equilibrium questions. So I have this question here which says that find the tension in cable BA and cable BC. So let's look at how we are going to solve this question. So I'll start by drawing my free body diagram. Okay. So let me draw my free body diagram. So I have this point to be point B, and then we have here to be D, and then we have C, and then A here. Okay. And then over here we have a mass. We are going to have a weight force there, which will be 60 kilogram times 9.81, okay, Newton. And then over here, because the weight is pulling down, the tension force will be in this direction, just to keep it in place. Okay. So we're going to have TAB here. Then we're going to have TAC here. Sorry, we're going to have TBA. Okay. TBA and then TBC. Okay, and then we know that TBC makes an angle of 45 degrees with the horizontal, and then for this side also, we've been given some values which is 4, 3, and then 5. Okay, let's take this angle here to be theta. Okay, so this will be our free body diagram now. Okay, so what we have now is that we have a 2D system, okay, where the forces are concurrent. If I say concurrent, it means that the line of action of all these three forces intersect at a common point, which is what point B here. Okay, so because of this concurrent system, we are going to use just the two force equations, which is the sum of forces in the x direction equals zero, and then the sum of the forces in the y direction equals zero. You will now have to consider this third equation. So for that reason, you will have to find the components of the forces since TBC and TBA at an angle. So let's look at how you're going to find the components. So we will start by finding the components for TBC. So for TBC, it will have an x component in this direction. So let's name this TBCX, and then to have a y component which will be TBCY, right? So let's find a component. So cosine of the 45 degrees, okay, will give me the adjacent side, which will be TBCX over the hypotenuse, which is what TBC. So you're going to have the x component to be TBCX, okay, and then that will be equal to TBC cosine of 45 degrees, okay, and then the y component, which will be TBCY, okay, that will be equal to TBC sine of 45 degrees. Okay, so let's do same for TBA also. So for TBA, we have you see that we have some small triangle, okay, which we have values 4, 3, and 5, right? And then this is the angle theta. This theta will be the same as the angle that the tension TBA makes with the horizontal, okay? So cosine of this angle will be equal to the adjacent, which will be 4/5, and then sine of this angle theta will be equal to opposite over the hypotenuse. Okay, so at this point you can find theta, okay, if you want to. So you're going to see that theta will be equal to the cos inverse of 4 on 5. Okay, let's see what you're going to get. So the cos inverse of 4 on 5, that gives us a value of 36.87 degrees. Okay, you can also use this also, which will give us the sine inverse of 3 on 5. Let's try that. The sine inverse of 3 on 5. That also gives us the same value. So we have theta to be 36.87 degrees. Okay, So considering the x and y component of TBA, okay, this will be the y component. Sorry, this will be the x component, and then this will be the y component. So this will be TBA x, and then I'm going to have TBA y here, right? So let's take cosine of the angle. So I'm going to have cosine of theta, okay, will be equal to the adjacent, right, which will be TBAX over TBA, right? So I'm going to have TBAX to be equal to TBA, right, cosine of theta, but it is pointing the negative x as direction, so we will have to what, negate it, okay? So I have the negative here, okay? So at this point, you know that cos theta is equal to 4 and 5, right? So we can substitute it there, or we can use the angle itself. So you are going to have we can write this as minus TBA, okay, multiplying 4 on 5, because cosine of theta is equal to 4 on 5, or okay, you're going to have minus TBA, okay, cosine of 36.87 degrees. Okay, you can write this also. So let's see what you are going to get. Cosine of 36.87 degrees will give us a value of 0.8. So you're going to have minus 0.8 TBA. Okay, this is what you have. That will be for the S component of um, the tension in cable BA. Okay, so let's find for the Y. So for the Y also, you're going to have sine of theta. Okay, that will be because the opposite. So that will be TBAY over the hypotenuse, which will be TBA, right? So you're going to have TBAY to be equal to TBA sine of theta, right? So we can use either the angle or 3 on 5. Okay, so let's look at that. Let's go up. Let's go up. Okay, so we're going to have TBAY to be equal to TBA, okay, times 3 on 5. So that's what you're going to get. So 3 on 5 will give us a value of 0 0.6. So this will be 0 0.6 TBA. Okay. So that's what you have now. So you're going to have some of the forces in the x axis direction, and then that will be equal to, you have for TBC, so you're going to have TBC, okay, cosine of 45 degrees, and then for TBA that will be minus 0 0.8 TBA, okay, and then this should be equal to 0. And let's consider the sum of the forces in the y direction also. For that one, the first one will be the weight force, which will be negative, so that will be minus 60 times 9.81. That gives us a value of 588.6 Newton. Okay, and to be negative because it is pointing downwards. And then we are going to have plus TBC sine of 45 degrees. Okay, and then plus 0 0.6 TBA. Okay, this is what you are going to have. This will be equal to 0. Okay, so now you are going to use the substitution method to solve these two equations that we have here. Okay, so from the first equation, I'm going to make TBC the subject. Okay, so let's look at that. So we're going to have TBC, okay, cosine of 45 degrees to be equal to 0 0.8 TBA, right? So let's divide both sides by cosine of 45 degrees divided by cosine of 45 degrees. So this will cancel out this. And then I'm going to get TBC, okay, to be equal to 1.131 TBA. Okay, this is what you are going to have. So you're going to substitute this into the second equation. So let's look at that. So you're going to have minus 588.6 plus TBC, okay, which is now 1.131, okay, TBA, right, multiplying sine of 45 degrees, okay, plus 0 0.6 TBA, okay, and then this will be equal to 0. So let's simplify this and see what you are going to get. I'll take this value to the right hand side, right? So we are going to have 1.131, okay, multiplying TBA times sine of 45 degrees plus 0.6 TBA, okay, then this should be equal to 588.6. So let's simplify what you have on the right hand side. So we have 1.131, okay, multiplying sine of 45 degrees. That'll give us a value of 0.8 TBA, okay, plus 0.6 TBA. Then this should be equal to 588.6. So let's add these two, and then we are going to get 0.8 plus 0.6. That gives us a value of 1.4 TBA, okay, and then this should be equal to 588.6. So let's divide both sides by 1.4, both sides by 1.4. Okay, so this will cancel out this, and then let's see what you're going to get for TBA. So TBA will be equal to 588.6 divided by 1.4. So that gives us a value of 420.4 Newton. So we are going to substitute this into what you have here so I can get TBC. So we're going to have TBC to be equal to 1.131, okay, multiplying TBA, which is what, 420.4. So that's what you're going to get. So we have 1.131 times 420.4. Okay, so this will give us a value of 475.5 Newton. So that's how to solve this type of equilibrium questions. Thank you very much for watching this video.